Good morning, students. In the last session, we have discussed about how the covalent bond is involved in the carbon and its compounds. Today, we shall move on to the next other concept regarding the compounds of carbon in this session. Let's welcome once again all of you. Today, as we have discussed in the last class, most of the chemical compounds what you are using in our day-to-day life is all made up of carbon compounds. Now these carbon compounds are broadly classified into two major categories. One is known as organic compounds, another one is known as the inorganic compounds. Organic compounds means they are the compounds formed by carbon, whereas inorganic compounds are the compounds which are formed other than carbon. So all these organic compounds today are more in number when compared to inorganic compounds. What's the reason for this? Why we are using more number of organic compounds rather than inorganic compounds? So the reason for this is the very important property what we see in the carbon. In other words, today the organic compounds is existing in a large number is because of what we see the versatile nature of carbon. What is this versatile nature of carbon? A very important characteristic of carbon you see in this particular thing. And that particular property of the carbon which makes the large existence of the carbon compounds today is catenation. So all the carbon atoms are linked one another by means of a covalent bond because of this property which is known as catenation. Now let's see what is the meaning of this catenation. Yes, what is catenation? Catenation is nothing but a self-linking property of an element due to which a large number of its atoms can be linked with each other by covalent bond. So what actual meaning here is catenation is nothing but the self-linking property of the carbon atoms. So one carbon atom is linking with another carbon atom by means of a covalent bond. When carbon atoms links with another carbon atom in large number, it exists in what we call a chain-like structure. So that property is known as what we call catenation. So catenation is nothing but one carbon atom is linked with another carbon atom, like that many carbon atoms are going to be linked by means of this covalent bond and resulting in a large chain of compounds. So due to the result of this catenation, the carbon atoms arrangement in the compounds may be straight chain, branched chain or closed chain. So the meaning here is because of this self-linking property in the carbon atoms, today in all the organic compounds, the carbon atom are arranged in these three forms. One is a straight chain, another one is branched chain, another one is the closed chain. In few carbon compounds, the carbon atoms are arranged in straight chain. In few compounds, it may be in branched chain, or in some few compounds, it may be in closed chain. Now let us look into this straight chain arrangement of carbon atoms, branched chain arrangement of carbon atoms and closed chain arrangement of carbon atoms. How actually the carbon atoms are going to be arranged in the organic compounds because of what we call catenation. So you can see the image of straight chain, branched chain as well as closed chain of carbon atoms. Just concentrate on the carbon atoms, how actually it is going to be arranged. In the first image, you are going to see the carbon atoms are arranged in a straight chain, that is in the linear chain, and that is attached to the hydrogen atoms. But as I told in the beginning of the class, carbon has an affinity to combine with what we call hydrogen. So that's why we call them as what we call hydrocarbons. So carbon has got more affinity to combine with hydrogen, yes, but here what I am stressing here is you should look into the arrangement of carbon atoms, how the carbon atoms are going to be arranged. In the first image, it is in straight chain. In the second image, you can see the carbon atoms are in branched chain. In the third image, you can see the carbon is arranged in a closed chain, or what we can say the cyclic nature. Now, another important property of the carbon compound apart from the catenation. Catenation is one of the most important property. Apart from the catenation, there is another important property you see in the carbon compounds is known as what we call tetravalency. So just to recall, in the previous class I have discussed that carbon, when it is combined with hydrogen atoms, we say that carbon is going to be combined with hydrogen atom by means of 4 bonds which are going to be seen surrounding the carbon atom. So because of this tetravalency, carbon has an affinity to combine with the 4 hydrogen atoms or any other atoms for that matter by means of covalent bond. So whenever you see carbon is going to combine with other atoms, normally it combines with hydrogen more, even it can also combine with oxygen or other compounds. Whenever whenever they are going to arrangement like that, we see surrounding the carbon we can see what we call the 4 bonds. So as we know, carbon should always satisfied with what we call 4 bonds. That's why we use the word tetravalent, and moreover you know that the valency of the carbon is also 4, so that's why we use the word tetravalency. So tetravalency is the property where the carbon atom is going to be linked with the 4 other atoms or groups, any of the atom, by means of covalent bond. You can see here the formation of tetravalency in the carbon compound. Taking an example of carbon atom, you know that how the electrons are going to be distributed here. In the first shell, that is K, it has 2 electrons, and in the L shell it is having 4 electrons. So total it is having 6. So that arrangement of the 6 electrons can be seen here surrounding with carbon with hydrogen, and those arrangement of carbon and hydrogen can be seen in the form of a bond like structure or a line which can be seen in the form of 4 in number, that is none other than tetravalent. Next, move on to the classification of hydrocarbons. Now the hydrocarbons are broadly classified into 2 major categories, that is open chain compounds and closed chain compounds. Now open chain compounds are nothing but what we can see the straight chain as well as the branched chain, whereas closed chain are nothing but the closed compounds. Now these open chain compounds are also further categorized into 2 categories. One is known as saturated as well as unsaturated. Closed chain hydrocarbons are grouped under again homocyclic as well as heterocyclic. Saturated hydrocarbons are always represented by single bond, whereas unsaturated hydrocarbons will always double bond and triple bond between the carbon atoms. So saturated hydrocarbons are actually represented by means of a class known as alkane. Unsaturated hydrocarbons are represented by 2 classes, that is alkene and alkyne. Now in the closed chain compounds, again there are 2 categories, homocyclic and heterocyclic. The name indicates here cyclic means it is in cyclic nature, or what we can say the ring or a closed structure. But whenever you look into the closed form of the carbon atoms, if the similar atoms are going to be arranged in a cyclic form, then it is called as homocyclic. If any other atom other than carbon, if any other atoms are going to be arranged in a cyclic nature, then it is called as heterocyclic in nature. Further we shall discuss that in the next sessions about this unsaturated, homocyclic and heterocyclic. Now under homocyclic again there are 2 categories, that is aromatic hydrocarbons and alicyclic hydrocarbons. The meaning here is aromatic means the hydrocarbons which has the characteristic smell. Aroma means smell here. So compounds which are having smell are come under the category of aromatic, and those which do not have smell are come under the category of alicyclic hydrocarbons. So alicyclic can also be referred as aliphatic because these hydrocarbons are basically they are single bonded, and moreover they exist in what we call cyclic nature. So therefore means they are in the form of round structures or they are in the form of closed structures. So they are the single bonded compounds, no doubt, but though they are single bond, they are arranged in what we call cyclic form. That's why they are called as alicyclic hydrocarbons, and these compounds will not have any smell, but those which are having smell are come under the category of aromatic hydrocarbons. So this is about what we call the classification of hydrocarbons, or what we can see the organic compounds. Now let us look into the first important category of the hydrocarbon is what we call alkanes. Yes, now this is one of the most important class of the hydrocarbons which contains carbon single bond carbon. They are under the group of saturated hydrocarbons. So let us look into the features of these alkanes. Now first of all, alkanes are the class of hydrocarbons. If you start to write any of the hydrocarbon, so how whenever you write any compound name, or whenever you write any name of the organic compound which belong to the alkanes, those compounds are actually end with what we call ANE. So normally in the organic compounds, there are two important words. You just recall in the English class you have studied about the suffix and the prefix. You have already know that two words. Just you correlate here. Suffix and the prefix. So prefix is the beginning part of the word and suffix is the later part of the word. Now when you look into these compounds, whenever the organic compounds comes, if the suffix part of the organic compound name, if it is end with ane, then they come under the category of alkenes. Similarly, if the suffix part of the organic compound ends with ene, then it is alkene. Similarly, if it is end with yne, it is alkyne. As we have already seen in the previous slide, I have shown alkanes, alkenes and alkynes. So alkenes and alkynes are coming under the category of unsaturated, whereas alkanes are coming under the category of saturated hydrocarbons. So alkanes are all single bonded and all these compounds names are end with ane. Let us take an example here now. This is about the suffix part. When you come to the prefix, the prefix part of these compounds will named based on the number of carbon atoms, how they are present in the compounds, how many number of carbon atoms are present. So depending upon the number, we use what we call prefix, and for this prefix we are adding ane as a suffix, and that becomes the name of the compound alkenes. Now let us take the example here now. The first member that belongs to this particular class is methane. Now in the word methane, meth, what we use that as a prefix and ane as a suffix, as I told. So meth is actually pronounced as meth. Meth in the Latin word means one carbon atom. So if the carbon atom is present only one, then it is referred as meth. You are using the prefix. So the meaning of the meth is one carbon atom, and for that you are adding the suffix ane. It becomes what we call methane. Like that, if the number of carbon atoms is 2, then it becomes yeth. The prefix is yeth, and for that you are going to add ane. It becomes what we call ethane. So methane is the first member of the organic compound of alkanes where the number of carbon atom is 1. Ethane means where the number of carbon atom is 2. Like that we can go for different. Next, if it is having 3, then it is called as prop. That is the prefix you are going to use, and for that you are going to add the suffix ane. That becomes propane. Similarly, if it is 4, it is bute, and the name becomes butane. Like that it goes on till the number of carbon compounds which are end with 10. So totally the alkenes will consist of 10 organic compounds. Now for this particular class of compounds, in order to know, as we know that whenever you look into the organic compounds, the basic thing what you have to remember here is first, of course, the name of the compound. Yes, after knowing the name of the compound, so obviously we should know its molecular formula. So after knowing the molecular formula, we are writing one more important method here, which is called as structural formula. So till now we have not heard the word structural formula. You have know up to the molecular formula. Suppose in the previous class, it is in 9th standard, you have studied about, suppose if I say a compound name sodium chloride, you will tell NaCl. If I say calcium carbonate, you will tell CaCO3. So you know these formulas, which are referred as chemical formulas and also referred as molecular formulas. But in this session, you are going to study one more important formula, which is known as structural formula. So after knowing the molecular formula, then only you can able to write what we call the structural formula. But before you write the molecular formula of any organic compound of any class, you should know a general formula of that particular class. Now for alkenes, there is a general formula which is known as CnH2n plus 2. Remember students, the general formula of the alkenes is CnH2n plus 2, where C means carbon and H is hydrogen, and N stands for number of carbon atoms. So how many number of carbon atoms are there? So how to know the number of carbon atoms? You should know the name. By looking into the name of the compound, by seeing the name of the compound, we can say how many number of carbon atoms are present, as now we have discussed. So methane, if I say the word, that means there is only one carbon. So substitute that 1 in the place of N. It becomes now C1H 2 into 1 plus 2. It becomes C1H21 plus 2, that becomes H2 plus 2, that becomes C1H4, or also can be written as CH4. So CH4 will become the formula for methane. Similarly, if I write N is equal to 2, what it becomes the formula then? C2H6. Similarly for 3, C3H6. So like that you can write, if you substitute the value of N as 1, 2, 3, 4, you can get the formula of that particular compound. So like this, what I have explained, it is there in the table format now, you can see here. So if the number of carbon atom is N is equal to 1, then the prefix becomes meth, and you have to add the suffix ane, so it becomes the name of the compound methane. Then what's the formula then? CH4. As I told in the above formula, that is CnH2n plus 2, you substitute in the place of N as 1, 2, 3, 4 like that. So similarly, if N is equal to 2, then you know the name of the compound is ethane, and the formula is C2H6. If N is equal to 3, the prefix is pro and suffix is ane, so it becomes the name of the compound as propane. So propane means the number of carbon atom is 3 and becomes the formula as C3H8 by substituting in the formula CnH2n plus 2. Similarly, if N is equal to 4, the name of the compound becomes butane because the prefix is but. But means 4 means the name of the compound should become but only. If it is prop, it is 3. If it is but, it is 4. Then end with ane, it becomes a compound butane. So the formula is C4H10. Similarly, if N is equal to 5, we use the prefix pent. Pent stands for 5, so that's why we use the word pent. And again, the compound is pentane because they are all alkanes, so obviously they have to end with ane. So pentane, and the formula is C5H12. Then N is equal to 6, that is hex, it becomes hexane, C6H14. If N is equal to 7, it becomes hept, that is heptane, and becomes the formula C7H16. So now we can look into the structures of alkanes, as I told already. So now we have studied the molecular formula. To get the molecular formula, we should use what we call the general formula. But what now I am showing is the structural formula of the different compounds, how to write in a what we can see, the straight chain of carbon compounds, that is open chain compounds. You can write like this: methane. How to write the methane? You have to write one carbon atom, and surrounding you have to write 4 bonds. For that you have to add hydrogen atoms. Similarly for ethane, eth refers to 2, so you have to write 2 carbon atoms in straight chain. So for 2 carbon atoms you have to show single bond, and one carbon atom is satisfied with another carbon atom with a single bond, so then you have to write the 4 bonds, and then you have to attach the hydrogen atom. Similarly for the propane, you have to write 3 carbon atoms in a straight chain and attach for the hydrogen atoms. For that it becomes propane. Similarly butane, you have to write 4 carbon atoms, attach the hydrogen atoms. The next is 5 carbon atoms, which is pentane. Like that you can write for some remaining hydrocarbons. Now in the same manner, when you look into the structure, we can also write one more structure for these compounds, which are referred as electron dot structures. Now how to write the electron dot structures? The similar structure what I have written previously, that is how you have shown in the form of a bonded. In the same manner, in the line we can write what we call electrons. As we have already seen in the beginning of the class, I have told, instead of bond we can also represent them in the electrons. So the electrons can be represented in the form of a dot structure. So whenever there is dot and X, that is nothing but a bonded one. That is where we can able to write the line between carbon and hydrogen. So and we can able to mix up those carbon and hydrogen. Wherever the bond exists, wherever the line comes, there you have to write a circle and make it as what we call complete structure of an alkenes. You can see different compounds of alkenes by writing the electron dot structure. Methane, you can write first one, second one is ethane, third one is propane, and fourth one is butane. So as I told already, so I have shown two dots which are nothing but the bond what we have written in the normal structure. In the normal structure you have written the bond. In the place of bond you are representing the dots there. As I told, a single bond always represent a pair of electrons. So we have to write totally 8 electrons surrounding the carbon atoms, and then for that H and dot you have to write a circle, C and dot you have to write a circle, 4 circles, and then one big circle which unions all the 4 intersecting circles. Like that you have to draw the structure of the remaining hydrocarbons of alkenes. So children, with this we have completed the alkenes compounds in detail. So in the next class we shall discuss few more compounds of this particular chapter. Till then, bye, take care, be healthy. Thank you.